In the healthcare industry, healthcare providers utilize a vast amount of procedures and techniques to save people's lives, but in the process of doing that, there's always a risk for infections to occur. In cases involving injuries such as open wounds or something like necessitated breathing support, microorganisms can get into the open wound or get into the lungs through the breathing tube and increase the risk of infection. Central venous catheters are another example of this risk. Used for giving fluids to the patient as fast as possible, they also open the possibility of introducing microorganisms directly into the bloodstream. We call cases such as these central line associated bloodstream infections, or CLABSI for short. 1 in 31 patients are affected by healthcare associated infections every day, and of those affected patients, 49% lead to sepsis. 52% of patients with sepsis lead to death. Most hospitals designate the task of monitoring these dressing sites to ICU nurses, or in some cases, even hire a worker dedicated to monitoring dressing sites by themselves. When taking into account the amount of patients a hospital must care for, this task is dauntingly time-consuming and inefficient, a bad combination for an issue where time is of the essence to catch these infections early. Our solution to this problem involves the use of computer vision and object detection to automate the task of monitoring patients' dressing sites. By compiling a dataset curated from a variety of different skin tones, fake blood, pus, and different states of dressing site damage such as a peeled edge, thousands of images were taken at a variety of angles, lighting, and distances to train our model. Using an open-source RoboFlow 3.0 model, which utilizes YOLO v8 for its underlying architecture, our model accurately identifies precursors to CLABSI with an 88.6% precision, a 92.8% recall, and a 93.0% mean average precision. Our prototype works by attaching a camera directly onto an IV pole or a bedside frame. A laptop replaces an embedded system for our prototype and runs a Python program which triggers the camera to take a picture at a set interval of time. These pictures are then uploaded to a Google Cloud environment where a Firestore function is set up to automatically run the uploaded images through our model's API and return what results were detected. Now that we automated the monitoring of the patient's dressing sites, we need a way to alert nurses so they only need to act when necessary. Using Xcode and Swift, we developed an iPhone application that can be downloaded on a nurse's cell phone and can be used to quickly check on a patient's status, information, and even trigger the camera to take a picture at any time they want. Nurses can simply open the app and see a list of patients to quickly identify their statuses. Color-coded for visual simplicity, red markers are used to identify urgency, such as the detection of blood or pus. Yellow is used to indicate that the patient should be checked on soon, for cases such as a peeled dressing site or skin redness. Green is used to indicate that only the dressing site was found and no signs of danger or irritation were detected. Nurses also have the ability to take notes directly from their phone and upload them to a patient's directory. This allows other nurses to leave patient-related notes for future nurses dealing with these patients. By using object detection to automate the task of monitoring patient dressing sites and creating a mobile phone application that shares data from a patient to a nurse, we've streamlined the monitoring and execution process of dealing with early signs of infection in hospital patients. With this prototype, we hope to significantly cut down the time used to check on each individual patient for these issues, while also decreasing the risk of human error when overlooking signs of infections among the dressing sites.